Hi all, good morning. So far we have discussed the fundamentals in classes, methods, how a method takes parameters, how a method returns the entire object as the return value, and how a method takes passing object as a parameter. Now we are going to see the iteration and recursion in Java. You know that Java is also a structured programming language which supports the sequence selection and iteration constructs. Using for loop, while loop, do while loop, we can implement the iterative constructs. Like C and C++, Java supports the feature of recursion. Recursion means the function calls itself. For example, assuming that f is a function defined like this. You want to call a function f means in this stage the function f should be invoking itself. For example, here after some statements you need to place the same f. So in this stage we need to carefully specify the actual and the formal parameters, and for every recursion we need to specify clearly the termination conditions. So to specify the termination condition based on here the parameter, we need to specify here the parameter value is something, right? Or here define the termination conditions. Condition or termination conditions based on the formal parameter or some other variable. So it is better to have the termination condition based on the formal parameter. Then here you need to specify the actual parameter because here itself the function is going to be invoked again. This is to be a recursion. So base condition, right? When to call the recursion, right? Under termination condition, how long you need to continue the uh, process, right? You need to clearly specify the termination condition. Then these things are met, right? We can say recursion is correct logic to implement a problem. Otherwise, what you have to do means you need to avoid this recursion, and the thing can be implemented using iterative or iteration concepts. Can you remember how to define the value of n factorial? How to define the value of n factorial using recursion?
Sir, n into
n
factorial
into
of
n
n
minus
minus
1
1.
factor.
N into factorial of n minus 1. That is n into n minus 1 a factorial. In this stage, this is true when is a condition
N greater than 0.
base condition when n greater than 0.
0.
When to terminate the process, that is I write again here n factorial is equal to this is 1 when n becomes. So this is a termination condition, and this acts as a base condition, right? How long you need to continue the recursion. Recursion is evaluated normally using the stack, right? Using LIFO, last in first out order. I tell you right in the next example, right? How the recursion is evaluated using stack, last in first out order. So as of now, right, I don't want to write solve this example, finding the value of n factorial. I have taken a different example, right, to find the nth Fibonacci number. This will be found using iteration as well as recursion. And we need to sketch its trace for n is equal to 6. So find right what is actually the sixth Fibonacci number using iteration and using recursion. So coming to the code directly here, I used the util package a scanner class. So the package to be imported is import java.util. You can use star or you can use specific class because scanner is alone used here. So I have put right scanner import java.util.scanner. Class Fibonacci, one instance variable n is declared. Then get n, assuming that get n method which is used to get the keyboard input value. So enter n, right? The nth Fibonacci integer, that Fibonacci number that we need to find. Scanner is equal to new scanner of system.in. System.in is acting as the input stream object. The input stream object. So s dot next int retrieves the integer from the keyboard, and which is further assigned to the variable n that you know well. Then find the nth. This is the method void find the nth, right? A method. This is an iterative method. Iteration using iteration or repetition. Iteration or repetition. Assuming that right x is equal to 0, y is equal to 1. These two are the first two Fibonacci numbers. First number is assumed to be 0. The next number is assumed to be 1. Then the third number is obtained by adding the previous two numbers 0 and 1. Then the next number is obtained by adding the previous two numbers. Assuming the first number is 0, next number is 1. Third number is obtained by adding previous two numbers 0 plus 1, 1. Then last two numbers, right? 1 plus 1 gives 2. 2 plus 1, 3. 3 plus 2, 5. 5 plus 3, 8. 8 plus 5, 13. Then 21, 34, 55, etc. Like this, the sequence goes. So assuming the first number is stored in a variable x is equal to 0, and the second number is stored in a variable y, and we need to find out the next number by adding the previous two numbers at every iteration. So using the another variable, say z is initialized to 0. Par starts at j is equal to 3, since the first two numbers are initialized. So assuming that we do want to find the value of some n which is greater than or equal to 3. So j starts at 3, j less than or equal to n, right? Because we need to find actually what is the nth Fibonacci number. So when j reaches the value of n, right, the value of z is exactly 4. J less than or equal to n, j plus plus. Z is equal to x plus y. Z is a new number that is obtained by adding the previous two numbers, say x and y. Then we do want to change, right, y into x and z into y, because after finding 0 plus 1 is equal to 1, then the first three numbers are obtained. Next to find out a value of 2. So this x, previous value of x is 0. That is updated from the value of y. X is equal to y. So this is a new value of x. And the current value of z is assigned to a variable y. So x is equal to y is equal to z. Updates the values of x and y so that the next sequence or next number in that sequence can easily be found. So clearly when j is equal to 3, the third number is obtained because z is equal to x plus y. Already x and y are two numbers obtained, initialized. Then likewise when j reaches n, the nth number is found and it is held in a variable z. Z is equal to x plus y. So the nth Fibonacci number is stored in a variable z and z is printed. This is using iteration or repetition concept. Next, to find the same using a recursion concept, consider the sequence of numbers. We do want to initialize, right, in terms of some variables, right, or array representations, or simply, right, we can write the previous number is, right, our first number is fib of 1, assuming that, right, 1 is the actual parameter, right. So defining in terms of, right, a fib of 1, fib of 1 is initialized to 0. Fib of 2 is initialized to 1. 0 and 1. First two numbers are initialized to the function calls, where fib is the function name or method name. 1 indicates that the first number, which is set to 0. And 2 indicates that the second number, this is set to 1. So these two are the initializers in this recursion. So how many initializers do we have in every recursion? Means we can have, right, one or more initializers, right, one or more than one initializers we can have. For example, factorial, right, we have, right, only one initializer, right. When n is equal to 0, right, we can return a value 1. But in case of Fibonacci numbers, since the two numbers are going to be processed at any time, we need to have, right, two initializers. Fib of 1 is set to 0, fib of 2 is set to 1. Clearly, if we assume, right, fib of 3, the third number in that sequence, fib of 3 is obtained by finding fib of 1 plus fib of 2. Fib of 4, fourth number is obtained by, right, finding fib of 2 plus fib of 3, that is fib of 3 plus fib of 2. Likewise, fib of n, the nth number in that sequence is obtained by fib of n minus 1 plus fib of n minus 2. This is valid when n is greater than or equal to 3. Putting n is equal to 3 here, the fib of 3, 3 minus 2 is 1, right? 3 minus 1 is 2. So, fib of 3, right? This expression is reduced. Since these two are acting as the termination conditions here, right? You can easily make the termination conditions whenever the actual parameter is equal to 1 or 2. So assuming that fib is the method name, which takes one integer parameter a, formal parameter, and assuming that the method is going to return the integer value, whenever the formal parameter a becomes 1, fib of 1, right, the value to be returned is 0. And when the actual parameter a becomes, sorry, formal parameter a becomes 2, the value to be returned is return 1. If these two conditions fail, then we need to return this recurrence relation. Recurrence relation is a recursive relation, right? So else, yeah, actual formal parameter is not equal to 1 or not equal to 2. So that is clearly greater than or 2 or greater than or equal to 3. So in that stage, we do want to return this expression, fib of n minus 2 plus fib of n minus 1, where n is your formal parameter a. So replace the value of n by a here, we will get return fib of a minus 2 plus fib of a minus 1. This is the simplest method which returns the nth Fibonacci number using recursion. Here the method name is fib. Same method name is placed right inside the method definition. So how many times you can place the same method name is you can place any number of times, right? One or more than one time, right? So here in factorial, right, only one time is enough. But in case of here Fibonacci number, you need to write twice because the previous two numbers should be added to form the current Fibonacci number. Having any queries in this method definition? Just the recurrence relationship is simply implemented, right? This is true when n is greater than or equal to 3. The termination condition is when n becomes 1 or n becomes 2. A recursion terminates. So here, no right hand side, right, method name. Method name is fib. Fib is not available here. Here also method name is not available here. So when the formal parameter a becomes right either 1 or 2, the recursion is terminated. Return 0, here return 1. Then inside the class, right, say class is 15, we have created one object corresponding to the class Fibonacci. Object name is say FOBJ. Then FOBJ.getIn, FOBJ.find n. Get and right retrieves the nth get n, right, retrieves the value of n. Then find nth, that retrieves the value of nth Fibonacci number using iteration. Then using recursion, right, since the method is returning the value to the calling place, we are directly processing the return value in the println statement. So fobj.n, fobj.n, right, say nth, the value of n is retrieved here. Since n is a public instance variable of class Fibonacci. Plus, right, the nth Fibonacci number is and the number is obtained right using this method name fib dot. So writing fobj dot fib, then the actual parameter is given as this value fobj dot n. So clearly this is the method call. The method call returns one integer number, right? The integer number is processed here and is printed. How it works means, for example, if you want to find out a value of 7, right, a 7 Fibonacci number, fib of 7 means, right, so letting the formal parameter a is equal to 7, the actual statement to be executed is taking if a is equal to 1, a is not equal to 1, 7 is not equal to 2. So else return fib of a minus 2 plus fib of a minus 1. Substitute a is equal to 7 here. So the statement to be executed is return fib of 5 plus fib of 6. Return fib of 5, right, again calls the same method. This is said to be a recursion. So in this stage, to evaluate fib of 5, the actual parameter is 5 here, but the formal parameter a receives the value of 5. Since 5 is not equal to 1 or 2, in this case, return fib of 5 returns return fib of 3 plus fib of 4. Likewise, fib of 6 is evaluated to have fib of 4 plus fib of 5. Then further return fib of 3. Fib of 3 means, right, actual parameter is 3. Here A receives the value 3. 3 is not equal to 1 or 2. So further split up can be made. Then this returns, right, return fib of 3, right, return fib of 1 plus fib of 2. Then fib of 4, right, returns fib of 2 plus fib of 3. Then a fib of 4 plus fib of 5, right, that can be extended. Then fib of 1, right, fib of 1 is, right, 0, fib of 2 is 1. Then the fib of 2 is 1, fib of 3, right, fib of 3 is evaluated further to have fib of 1 plus fib uh, of 2, right. So that's why it returns 0 plus 1. So finally combining all the expressions, right, the expressions are evaluated and the final return statement, right. So using last in first out, right, the expressions are evaluated using stack, and finally, right, the value 3 plus 5, 8 is returned to the column. Java C classes 15.java Java classes 15. Enter n. Say we do like to find the 10th integer. 10th Fibonacci number is say 34. A 10th Fibonacci number is 34, right? Using iteration and using a recursion. One first number is simply 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10th one is 34. Having any queries in recursion and iteration?
Sir,
Sir, can the function being called be in the same class as the main class, sir? Main function.
Function, for example, method. Here, method is defined inside the class. What is our class? Fibonacci. Here, method name is fib. Fib is once again, right, introduced or at least one time introduced inside this method definition. This is in a separate class. In a separate main method class, we do like to create an object. So calling that method name requires, right, the corresponding object name dot method name.
Sir, I'm asking whether we can define the same function inside the class where the main function is there and call them inside the main class.
Inside the main class, here you would like to define a main method. Here, am I right? Recursive methods will be defined here. This is a query.
Ah, yes, sir. Here only, inside the class as 15 class.
Yeah, that is possible, right? In that case, right, you should not have this user defined class. So try to cut this into the main method, right? And you try to call that. But normally, right, many times it try to write separate the user defined classes from the main method class. Even we have seen so many examples in that no user defined class is defined, right? Only inside the class we have defined which one, the methods and are simply, right, we have defined the main method in only one class, right? So inside this we have defined what one means the necessary coding. But if you want to ask whether is this recursive definition is moving to place inside the main method, right? Inside the main method,
Sir, not inside the main method, sir, but inside the class outside the main method, sir.
yeah, inside the classes 15 or part of classes 15, okay. As we did earlier, right? You can use only one class. Main method is defined in that, right? That is possible. User defined class, right? Instance variables can also be defined in that. That is possible. But inside the main, right, this is not possible. But right, separate the user defined classes from the main method. That's a good logic. Having any other queries? I'll move on to the next one.
Sir, here we cannot involve.
Yes, tell me.
Sir, here we need not pass the parameter, no, sir. Like we are passing the parameter obj.n, no, sir, because we are invoking the
Mm.
because we are invoking with the Fibonacci object only, no, sir. Because when the Fibonacci object is invoked, we need not pass the 10 parameter, no, sir.
Actually, we do want to find the nth number in that sequence. So what actual value of n, right, that need to be possible. If not, right, what we have to do is here, right, in the find nth method, inside the part of this find n, to say here, right, what we have to do is you can get a value of n. Please enter the value of n. So that stage, the actual parameter f_obj.n is eliminated. You can leave the actual parameter is empty. Here also the formal parameter is empty, right? In case of iteration, no problem, right? Here
Yes.
inside this you can
Because
get the keyboard input value. But in case of recursion, right, you do want to find out the nth Fibonacci number means better to provide the value of n in the actual parameter list. Because here, right, if you are getting the value of n, every stage when the recursion is executing, right, so part of this method, all statements get executed. So
sir,
better to provide.
instead of providing that argument, because instead of a, we can directly define n inside of the class, no, sir. Because we are invoking with the same object, no, sir. Like here you are writing a equal to 1, so instead of that we can write if n equal to 1, n equal to 2, like that. Because this will invoke again, we need to create a copy of the object, no, sir. But it is not required because we are invoking with the class object only.
Here the value of a, you are saying,
We can remove that int
uh,
a, sir. We need not have that parameter and we can write directly n equal to 1.
if n is equal to 1, 1 minute, in case if you remove the formal parameter, right? So
Yes,
carefully understand, this will become blank, empty.
yes, sir.
If you write n is equal to 1, return 0, no problem.
Yes,
If n is equal to 2, return 1, no problem. Assuming that n is already initialized. For example, here itself you can initialize int n is equal to 15, no problem. That is perfectly valid. These two statements are also valid. Here, carefully understand, if, right, you have to use n minus 2. Here you need to use n minus 1.
yes,
You are evaluating the expressions in terms of your actual parameter. Here a fib of something means this is completely the expression which results in the actual parameter. Say n is equal to 15, 15 minus 2, 13. Here what happens? 15 minus 1, say 14, say 13 and 14. So next stage what will happen means it checks the value of n. N is equal to 1, n is equal to 2. At any stage, right, what will happen means you will have the value of n is equal to, you will not have the value of n is equal to 1 or n is equal to 2. Since we already fixed n is equal to 15, the value of your setting n is equal to 15 will never affect the if conditional statement. So infinitely, right, cyclically, right, your method will be executed. It will not terminate.
okay, sir.
Recursion
Thank
will
you, sir.
not terminate. So that's what I said, right? To terminate the execution of the recursion, right? What you need to specify means carefully specify the termination conditions. Mostly the termination conditions are specified based on the actual and the formal parameter values. So here, when the formal parameter becomes 1 or 2, recursion terminates because you are making the changes inside here this actual parameter expression, right? This change, right, should be reflected in the corresponding formal parameter. Otherwise you try to think of, right, writing some other expressions, return some a local variable temp is equal to a minus 2 and some other local variable temp2 is equal to a minus 1. You can try to use fib of temp means again that will be a problem. Because now what will happen means you got one variable means here you must introduce the variable. So carefully specify the termination conditions based on here the formal parameter. Next, right, and the same way, right, recursion can be applicable in different things, right? You can evaluate the value of factorial, you can evaluate the value of binomial coefficient, you can find the greatest common divisor between two numbers, right? Using recursion, you can search, right, if the given element is available in the array or not using recursion. You can implement a linear search using recursion. You can implement a binary search using recursion. You can find the maximum element in the given array using recursion, minimum element in the array using recursion. You can find the product of two matrices using recursion. So this way, right, recursion finds many applications. One more application I would like to say, define and initialize a one-dimensional floating point array with some random numbers. We do want to print the contents using recursion. That means we do want to define one-dimensional floating point array using random initialization, and we need to traverse the contents of the array using recursion. So print its contents in the sense that whatever we are having in that array, starting from x of 0, x of 1, x of 2, etc., x of array size minus 1. In that order, we do like to print its contents. That is the problem. This is not printing the contents in some random order. So using utility package, we do like to write use the random initialization. A float X array, random init is our class, user defined class. Here random init, right, access the constructor, and one value, right, a is passed so that the size of the floating point array is initialized. This is also a good logic, right, to define the initialization of the array. A float X array, right, array is declared here, but here whenever you want to create an object, for example array size, because here all arrays are dynamically created, right? So in that stage you can specify the size here, new random init of size, say size is 20. So during the runtime, right, the value 20 is passed here. Now x is equal to new float of 20 memory locations are allocated using the constructor. Then for initialization, right, you try to call the next float method. Random, right, create the random class object. Random is a class which is defined in Java's utility package, right? So to access that, you need to import java.util.random. Random object is equal to new random based on the length of the array, right? Because length is the normal instance variable, which is actually available in every array when it is declared. So x dot length, which returns the size of the array. X of I is equal to r obj dot next float, right? Next float, what will happen means, since r obj is an object of a random class, randomly which generates uniform random numbers in between 0 to 1, right? So those random values are assigned to the floating point array x of I. This is for our initialization, initializing the one-dimensional floating point array with some random numbers. Then have a look into this recursion, how the contents are actually printed using recursion. That means how do we traverse the entire contents of the array using recursion.
Excuse me, sir.
Yes.
Sir, when we are using a parameterized constructor, we need to use a default constructor.
Parameterized constructor, we need to use a default constructor only when you call a default constructor. I clearly explained in the previous examples. Here, for example, random init of size, we are calling the parameterized constructor with one parameter. In case if you do not call the default, sorry, if you are calling a default constructor, say new random init, right, no parameter, that stage, right, what you have to do means you need to redefine the default version of the default constructor. So that
Sir,
stage
we are
random init.
initializing default. Here we are not specifying any size, no, sir. In initialize random object.
Yeah, here we are passing the size here. Look into here. New random init of size. Size is actually obtained, right, through the keyboard input. That value is passed as a parameter to random init of size. So we are calling the parameterized constructor. In case if you are having the statement random object r obj is equal to random init r obj is equal to new random init, no actual parameter, means you are invoking a default constructor. And since we have defined the one argument parameterized constructor, there you must redefine the default constructor. Random init, dummy parameter, at least, right, the dummy definition should be introduced. Okay.
Okay, sir. Thank you, sir.
Okay. Now have a look into this recursion, right? How do we traverse the array, right? Using a recursion. I defined, right, one method, say print x bar, right? Now the range of x is, right, 0 to length minus 1, array size minus 1. Array size is usually obtained, right, using x length instance variable. X is the array name, a floating point array. So I ranges from 0 to array size minus 1. Then system dot out dot println x of I is equal to x of I. So what is this one? This is of course the iterative method, right? Iterative method. I ranges from 0 to length minus 1. We can directly print the contents of the ith index in the array, say x of I. That is printed. Now have a look into this one. This is a recursive method. Print x. Print x, right? We require one formal parameter a. A is one integer variable. What are you going to do means we can specify one termination condition. If a is equal to 0, return. We have discussed already, right? A return semicolon. That stage, right? The method type. Return type of the method is void because void is a dummy return, right? Dummy return will not return any value to the calling place. So return type is void. If a is equal to 0, right? When the actual parameter a becomes 0, then the formal parameter a becomes 0. The value to be returned is nothing. Simply control is returned. Here, what is actually a means, right? We are traversing the indices, right? Array indices are traversed. When the array index becomes, right, here 0, right? We are returning the value, dummy value is returned. Else print x of a minus 1. Suppose array value is 5 means, right? Array size is 5. We are passing 5 here. 5 minus 1 is 4, right? Print of 4. What is print of 4? Array size is 5. Array size 5 means, carefully understand, indices ranges from 0 to 4. So print x of 4. Print x of 4 means, right? What will happen means, uh, then it again invokes the recursive method. So a becomes 4. A is non-zero. Then print x of 3. Then print x of 2. Print x of 1. Right? Print x of 0. Print x of 0 means, right? Dummy value is returned. Before that, print x of 0 means here already we have the value. What will happen? 1. Print x of 1. Print x of 0. 0 means dummy return. But here, right, I use the value of a minus 1 because we need to access the values from 0 to array size minus 1. Since the statement system dot out dot println the expression, right, x of a minus 1, the statement is going to be placed into the stack, right? So when a is equal to 5, 5 means, right, what will happen? 5 minus 1, 4. X of 4 is placed. Then next statement x of 3, x of 2, x of 1, x of 0. X of 0 is finally placed. So that stage what will happen means x of 0 last in first row, x of 0 is first printed, x of 1 is next printed, x of 2, x of 3, x of 4. So in that order using stack last in first out evaluation, last in first out evaluation, the array elements are printed from 0th index to array size minus 1 index. This is one possible recursion. If not, right, we can use, right, two parameters means like this. We can do print x array method name int a comma int j. Here I have designed system dot out dot println x of j is equal to x of j, right? So j, right, j what I have to do means I need to pass the values j because first element to be printed is x of j. Then I am incrementing the value of j by 1. Then I am checking, right, if a is equal to 1, right, return, right? What is the value of initial value of a means I need to pass the actual array size and I need to decrement the value of a by 1. If a is equal to 1 means return, dummy return, else print x array of a minus 1, right, 5 minus 1, then 4, 3, 2, 1, like that, right? The values are decreasing. Then inside the main method, we have defined the array size as the input variable. Then input size is obtained into the variable size, which is passed as a parameter to the random init constructor. Then initialize method is called. After that, we have printed the contents using iteration. Then two possible recursions are called. I show the Right screen. Java C classes 16 dot Java. Java classes 16. Enter the array size, say 5. 5 numbers are initialized because this is the uniform initializer. Random samples are sampled from the continuous uniform distribution where the probability density function is given by f of x is equal to 1 by b minus a, where a less than or equal to x less than or equal to b. So continuous uniform random numbers are simply sampled from the continuous probability distribution whose range is 0 to 1. Simply saying in between 0 and 1, the random numbers are generated and are assigned to the corresponding array locations x of 0 to x of 2 since the array size is 5. Printing the array elements using iteration, right? Iteration, these are the values. Then using recursion, right? First x of 0 to x of 4 up to this, right? Using the first recursive method and the second recursive method prints the same content. Having any queries?
Sir, can you explain the function print x array once again, sir?
Print x array. This one.
Yes, sir.
It's very simple, right? No confusion here. Have a look into this function call, sorry, method call, right? Size comma 0. Suppose size is 5, right? 0 is the initial value. Why I have used 0 means since we do want to start from 0th index, size is 5. The second parameter is 0. So A receives the value of 5, for example. J receives a value 0. X of 0 is printed. So X of 0 say something 0.89 right is printed one time. Then J is incremented by 1. Currently J is 0, now J becomes 1, right? Checking if A is equal to 1, A is not equal to 1, right? Else print x array A minus 1 comma J. What is the purpose of this if statement? It just returns the, it just terminates the recursion and returning the control to the calling place. Now J becomes 1, right? A minus 1. A is right previously 5, 5 minus 1, 4. 4 comma 1. 4 comma 1 means right the first location is printed, x of 1 is printed. Then J becomes 2, right? 4 1, then it becomes I think 3 2. 3 2 means right what will happen? X of 2 is printed. 3 2, then what will happen? 2 3, right? The third location is printed. Then 2 3 means next, right? 1 4, right? Fourth location is printed. X of 0, x of 1, x of 2, x of 3, x of 4. I think first 5 memory locations are printed. Finally, right? What you said? 1 4. So when A becomes 1, right? This is actual parameter. This is reduced to 1. Now this A receives a value 1. When A becomes 1, return. Just terminates the recursion. So the control is returned to the calling. As far as this print text is concerned, just only the array size is passed. Array size is, carefully understand, array size is 5. Checking if array size 5 is equal to 0, it's not 0. So else print x of A minus 1. A minus 1, right? 5 minus 1, 4. 4, right? Lost in first out. So print x of 4, right? Further invokes print x of 3, 2, 1, 0. When this becomes 0, right? Return. Before that, the statements are to be executed in the last in first out order because here 5 means right to 4, right? So that stage after the recursion, the statement to be executed is here x of 4. After that, x of 1 is placed in its top, then x of 3, x of 2, x of 1, finally x of 0 you have. Since all these statements are placed in a stack, right? It seems that x of 0 is available in the stack first. So x of 0 is printed, x of 1, x of 2. The first statement that he have put, right, into the stack, that is inserted into the stack, is going to be evaluated at the end because stack are LIFO, last in first out data structure. Having any queries? Likewise, you try to evaluate the values of n factorial using recursion, Then GCD, right, greatest common divisor or greatest common factor between two numbers using recursion, right, and some other recursive applications. Then I move on to the next one. We have seen, right, 16, then 17th one, static keyword. Java supports a static keyword, right? So far we have seen the static keyword which is used to define the main method. Because before creating any objects of the class, the static keyword is going to be called. There are some other purposes of static keyword. Static, which can be used to define the instance variables, and static can also be used to define a block of code, sequence of code. It seems strange, right? Using static block of code. Have a look into this class static. A and B are, right, non-static variables. A and B are non-static variables, where C and D are static instance variables. The important thing of static instance variables are all static instance variables are initialized to 0 when the first object of the class is created. No other initialization is permitted, right? So the remaining objects, when you create the second, third, fourth, etc. objects, all static variables are assuming the same value. So it seems that static instance variables are equal to global variables. You know the meaning of global variables. We are creating 5 objects, right? For all the 5 objects, we need to have only one memory location or one memory allocation. To allocate that, right, the instance variable should be declared as a static one. Static into C comma D means only one time memory is allocated, right, when the first object is created, and for the remaining objects can use the same memory location. That is very important. So if you change the value of variable using any one object, that will be reflecting in some other objects, because static instance variables are equivalent to global variables. Then you can define a static block like this, right? It seems strange, right? As I said earlier, static, opening curly brace, closing curly brace. This is a syntax to define a static block. The purpose of static block is, right, if you want, you can define some initialization, right? I have given some comment, right, to check in what order the static blocks are called whenever we have more than one static blocks. That's we need to check if more than one static blocks are allowed in Java. Yes, you can define more than one static blocks inside the class. That is perfectly valid. So calling static block 1, inside that, right, I do want to print the values of C, D, and here I do want to initialize non-static variables means this results in a compile time error, because static block can initialize only static instance variables. Likewise, it can call static methods only, right? Non-static methods cannot be called inside the static block. And have a look into this, right, exploring the methods, right, or two methods. One is a static method and another one is a non-static method. So far we have seen the methods which are all coming under a non-static category, because the method is not preceded by a static one. In this example, right, this is of course a static method, static void, static m1, right? Since this is a static method cannot access non-static variables, right? Static method can only access static variables, right? So calling a non-static method, this results in a compile time error, right? So these are the rules of having a static keyword. Static keyword can be used to define methods as static. Static methods can access only static variables, and it can call some other static methods. So likewise here static method m2. You can check if m1 is called here, right? M1, what is m1? Static m1 is a static method. So m1 can be called, right, inside another static method. And have a look into this one. This is a non-static method, right? Void non-static, for example. Method name is non-static. Non-static method, right? Here we do want to access all the variables a, b, c, d, right? These are possible. Printing the values of a, b, c, d. Then here another block is defined after one method, calling static block 2. Then, right, another method, another block is defined, static block, right, 3. So in what order the blocks and the methods are going to be executed means, at the time of creating an object, right, here when the first object is created, what will happen means we can see that the static instance variables are initialized, right? By default, static instance variables are initialized to 0. Then in what order the static blocks are defined? This is the first static block, and this is the second static block, and this is which one? The third static block. So after initialization, the static blocks are called in the sequential order. You try to check the code. Static instance variables are initialized, right, only once, first when the main method is loaded. Then static blocks are called in the sequential order. You can define any number of static blocks like that. So in that order, the static methods static blocks are going to be called. Then we have created some objects for the static class, and we have called, right, the non-static methods and the static methods. So as far as this is concerned, the rules are, right, very simple. uh, Static methods, right, can call other static methods. Static methods can access only the static instance variables. Here non-static methods, right, accesses the variables a, b, c, d, right. Then to access the actual static method, there are two possibilities. Very important point. As usual, you need to create an object of the class static and call the static methods. That is one possibility using the object name. Other one, the simplest level, use the class name dot static method. Class name is, for example, static, right? Method name is, say, static m2. Using method name and a class name, right? Static method name and a class name, you can simply invoke the static methods. Here I have illustrated some other things, right? SOBJ once, right? C and D are set because C and D are static instance variables. Setting the value of SOBJ once C and D locations, right? We try to print the contents of a SOBJ 2, 3, right? This will be reflected. Setting the value of SOBJs 3, C and D, this will be reflected in SOBJ 2's C and D locations. So we try to go through these rules. Non-static variables cannot be accessed in the static method. So reverse is static method can access only static variables. That is the meaning. Only static variables can be accessed in the static method. Another rule, for rules 1 and 2, right, both are same. Non-static variables cannot be accessed. That means static variables only be accessed inside the static method. Static method can access only other static methods. With respect to method call, right? Static method can call only other static methods. Static, that means static method cannot access non-static methods. Right? 3 and 4 remains the same. Non-static methods, this is a very important one. So far, the methods that we have discussed, right, are all come under this category. Non-static methods can access both static variables and static methods. Since here, for example, non-static, this can access, right, both static variables as well as static methods. Non-static, whatever non-static methods can
Sir,
access both.
excuse me,
Yes,
sir.
yes.
Sir, in the case of C++, when we are initializing a static variable, we need to define the static variable also, no, sir? Here, the declaration and definition will be same, sir.
Here, there, right, somewhat different one. Following the class declaration, you need to make the initializer using scope resolution operator.
Yes, sir.
Here, that's what I say. There, the syntax is somewhat different from compiler to compiler. Following the class declaration, you need to type, right, a static int the C is equal to 100 something. But in Java, it's very simple. Here itself, if you want, you can initialize static int C is equal to 100, D is equal to 200. Otherwise, the default initializer is 0 for integer variables. So go through these rules, right? Non-static methods can access both static variables and static methods. Sixth rule, when creating the first object, static blocks are executed in the sequential order. That's what I said, right? When the first object is obj1 is created, be careful, right? You try to run this code, right? When the object SOBJ1 is created, you cannot see the message SOBJ1 is created. Before that, that means at the time of creating SOBJ1, automatically the blocks inside the class are going to be executed in the sequential order. So you can see the message calling static block 1, static block 2, static block 3, right? In that order, the static blocks are executed. All static variables are initialized to 0, right? Numeric in the case, right? You only try to check what about for character and the boolean, right? There is a query. Non-static variables and the methods, right, cannot be accessed in a static block. This is the same rule as that of a static method, right? Static method can access only static variables and other static methods. So non-static variables and methods cannot be accessed in the static block. Above all, static instance variables are global variables because the entire objects of the class, right, are sharing the same memory location. Only one-time memory is allocated. So that's what I tried here, setting the value of static instance variables C and D through one object SOBJ1, and you try to print the contents of SOBJ2 and SOBJ3, you have the same values of C and D because essentially C and D, the static instance variables are of a global variables. The way to access a static instance variable or methods are twofold. One, as usual, you can use the object name, right? Object name means you can use object name dot static variable or object name dot the static method. The simplest way to access a static members are using the class name dot static variable and a class name dot static method. Better example, we have already seen integer dot parse int, float dot parse float. There integer float, those are classes. Parse int, parse float, that are those are static methods. So using class name integer dot, right, static method name is parse int, we can directly access without creating an object. Another question I do want to ask you, right, is a recursion supported, right, with respect to be a static method that you need to check it. Try to run this code, right, and verify the rules of having static blocks, static instance variables, and static methods. I move on to the next one. Final keyword. The keyword final can be used to define some symbolic constants, right? In C, right, we have to use hash define, then strength, right, 125. In Java, C++, right, you need to use const into strength is equal to 120. Where in Java, you need to use the final keyword. Final data type variable name is equal to value, right? So once the variable is initialized with a final constant, the constant cannot be, right, modified. So writing strength plus plus or pi minus minus, this results in a compile time error because final modifiers, right, variables cannot change the corresponding values. Once it is declared, that's all. That's a final value. Next one, how do we find the size of an array? The size of an array, right? What is length actually, right? Length is actually the instance variable which is automatically available whenever the array is constructed, right? So in this example, int x array is equal to new int of 250 means clearly the length of the array, size of the array is 250. ch1 dot length, right? 1 2 3 4 5 character array, right? Length is 5. ch2 dot length, ch2 AEIOU. Don't confuse from C, C++ to Java. Here, array initializer, right, does not end with this null character in terms of character arrays, right, compared to C and C++ arrays. So here /0 is also taken as a one character, right? So this is not a null one, right, with respect to C and C++ one. Of course, a null character, but this null is not required, right, to terminate the actual initializer of a CH2 array, right? So
So
any
then
of
now the scanner stops reading the character arrays.
how the
Our scanner stops reading the character array, so because we may define the character array, the size of the character array may be larger than what we the input we give, no sir. So if we want to read the correct input what we want, then how could we do for character arrays?
In that case, right, the built-in methods, say read method, readline methods, those methods are designed in such a way that whenever the null character is reached, right, the actual input is going to be terminated. In that way, the methods are predefined methods are defined. here including null, right? The character array size is taken ch2, so 0 is also counted in its length. Likewise a double array, right? The total number of elements are 7, that length is printed. Next, float f array, right? After this you cannot use f dot length because f is not allocated a memory, so you cannot access a length variable, right? This results in the error. Then f is equal to new float of 100, then 100 is okay, memory size. But setting x is equal to null means, right? If you print the value of length of x, right? X dot length means, right? What will happen? You try to check that x is equal to null. What is x? X array. X array has been set to null, right? Null means, right, no memory locations. All memory locations are cleared, right? You cannot access any value in that, right? Then length, right? To try to find out the actual value of length, x dot length, when the array is set to null. Then revisiting the access modifiers, right? Private, public, and the protected, right? By default, int x is same as public int x. If not explicitly, you need to define the variable as public one, public int y. Private means, right, the variable cannot be accessible outside the scope of the class. However, the private variables can be accessible or through the methods of the same class. For example, here in int x, y, z. Yes, in the method get x, y, z, right? You can access the private variable and a private method. Say get is z. Get is z is called here. But outside the scope of the class here, for example, here you cannot access a obj dot get is because what is get is it? Get is a private method. Private method cannot be accessible outside the scope of the class. But this method can be accessible, our variables can be accessible using the methods of the same class. Those methods can be applied to private, public, or a protected scope. A protected can have a significant only in inheritance, right? So later we see, right, the concept of inheritance. Then you try to go through these things, right? Nested and inner classes. You can define one class inside another class, right, which comes under a category of nested classes. And exploring the string class, right? A string class provides several methods, right, to perform the operations, like a string comparison, finding the character at a particular location, checking, right, if the two strings are equal or not, concatenating multiple strings or multiple string objects, those things, right? You try to go through this, the string class methods. Then command line arguments, right? Already we have discussed during the runtime. We can provide some input values. Those are acting as command line inputs to the main method. Another one, variable length arguments. Variable length arguments means during the main method, right? You can pass, right, any number of values to the method. Normally, a method call takes some parameters. How many values you can assign means that are not limited. You can pass the entire array as a value to a method. That is possible. So in this example, a three character array ch1, ch2, ch3 are going to be passed as a parameter to the test method. Test of ch1, ch2, ch3, and one empty array is passed into a array is equal to empty, no memory locations. So in that case, right, here we do want to print the contents of the actual parameter array. To print the actual parameter array, we are finding the number of arguments. To find the number of arguments, we can use array names length instance variable. Array name dot length instance variable. And this is a short form of for loop. Have you noticed this kind of for loop? Normally you will be using for int I is equal to 0, I less than x dot length minus 1, I plus plus, and you will be writing x of I, right? So in the later versions of JDK, right, the simplest version of for is supported. You try to go through the control statements chapter, right? You can easily find that this simplest version. For into j colon x means, right, x is the actual array name. The actual array name x is traversed using the variable j. So if you write simply j means, right, j ranges from x of 0, x of 1, x of 2, x of array size minus 1. That is very important. Printing the value of j means, right, yeah, at every stage, right, the iterator iterates the elements in the array x. So printing j means what will happen means if you put right int is the data type, right? Here same data type. Char means char, float means float, double means double. Boolean xarray means here boolean should be introduced, not int. So printing the value of this variable, right? Data type variable. This prints this simply right iterates the value of x array, x of 0, x of 1, x of 2, x of 3. For example, I run this code java c access21.java. Access21. You can see the number of arguments. First array 1, 2, 3, 4, 5. 5 is extracted. How? X dot length. X dot length is 5. Then the contents are printed. A, E, I, O, U. Actually, character array. Since this is an integer array, character to integer 1. As I said, right, J what it prints the value of x of j. The sorry, value of x array contents. Starting from first location, x of 0. X of 0, ASCII value of A, 97. Then ASCII value of E, 101, I, O, U. Likewise here, A, E, I, O, U, right? Null ASCII value is 0. Then number of rows, right? The next one, the integer array, 10 values, number of arguments, right? 10 contents are printed. Last one, number of arguments, right? Simply total number of values. What is array size? Array size is 0, right? Having no elements. So array size returns a value 0. Contents are right null. No contents are there. Simply blank is printed. This is a older style, right? Normally in older style, we need to define the printing or finding, right? Passing the array values like this and processing the array values using this representation for into j colon x. But in the newer style, what you have to do means you need to introduce triple dots. That's very simple. Have a look into right previous version with this version. There we used what we used previous version int x array we used here. Three dots are introduced. 1 minute, 22, then I think 21. This is the older version int j colon x. But in the new year version, right, what you have to do means you need to use a triple dots. So in that case, right, you need not worry about the actual parameter. Here what will happen means here actual parameter 5 values are passed, 6 values are passed, 10 values are passed. You can pass any number of parameters, any number of values. Have you noticed that? We have already discussed that Java is a strictly typed language. There must be a one-to-one correspondence between the actual parameter and the formal parameter. Very important rule. Actual parameter, how many number of actual parameters you are specified, same number of formal parameters must be specified. There must be a type compatibility, right? Data type compatibility between actual to formal parameters in terms of left to right route. Here in the previous example, have a look into this one. ch1 means when the array name is passed, the entire array is passed as a parameter. In this example, you are passing multiple values. These multiple values are received in the integer array x. In variable length arguments, when we introduce the triple dots, you should not define int x array here. If you write int x array and using these values, this results in a compile time error. So when specifying multiple values like this, what you have to do means formal parameter should be declared an array which is represented using triple dot operator, right? So int triple dot x means by default here x is an integer array. How many values you are passing here? All are received in the integer array. Understand or not? Five values are received in the integer array. Then six values means six values are received in the integer array. Seven values are received in the integer array. So there is no significant difference between the previous output with this output. For example, Java classes 22. We can find Java classes 21, Java classes 22. Output remains same. But only thing is here multiple inputs are specified in the function call, method call, but in the formal parameter, array is not represented. For example, data type array name without specifying the size, as we did in earlier example. But using the triple dot, right, simply it receives variable number of arguments, variable length arguments. Arguments can be a variable, right? It can be changed. 5, 7, 8, 10. Any number of arguments can be passed, right, in the actual parameter list. All are completely received in the corresponding array type. For that purpose, Java supports this facility. Try to go through right after this. Let us continue right some other programs right in this topic in the next class, and we start inheritance concept in the next class. Having any queries?
Sir, should the list of inputs should belong to the same data type or it can vary, sir?
Which one? Could not get you.
Sir, you are passing the arguments, no, sir. They all belong to the same data type. Can it be of different data type?
Yeah. No, it should be a same data type. That's what I said there. Here, right, passing all values, right? A character means character is converted to integer one. This int, right, signifies a type. That's what I say. Here in this example, if you replace, right, int x array, similar to this one, int x array means this results in a compile time error. Because we are passing variable number of arguments here, right? In that stage, the skeleton should be represented like this using triple dot. So you cannot pass, right, integer float combinations, a character that will not be received here in variable length arguments. Certain rules are there, right? We try to explore these rules, right, in the next class, right? Variable length parameters. We share the files, right? You please execute these files, right, including a static method, right? I have not shown the demo for a static example. You try to run all the programs, and if you have any queries, you can ask. Already we missed 2 or 3 sessions, I think, in the last month because some Saturdays were holidays, right? So we try to cover the missing topics from this chapter in the next class, and we will continue right the inheritance concept, right, in the next class. If you have any other queries, you can ask. Okay, thank you very much. We will discuss in the next session.
Thank you, sir.
Thank you, sir.